Hi everyone, welcome to Saturday Night SQL Virtual Group webinar. My name is Sarah Huang. I'm the founder and organizer of this virtual group. Join me here is Debbie Huang, our co-organizer. Today, Brad Llewellyn will present an exciting topic, Azure Machine Learning Studio, making data science easier. Brad is a senior data science consultant at Centelli Solutions in Charlotte, North Carolina. Brad helps individuals and organizations revolve the data science world in order to figure out how it can work for them. He has an MS in statistics for the University of South Carolina, MCSE certification in data management and analytics, MCSE certification in cloud platform and infrastructure, and MCSA certification in machine learning. Brad is an active blogger at bloggingbi.blogspot.com. He's also an organizer for the Charlotte BI Group, a local past chapter in Charlotte, North Carolina. You can connect him on LinkedIn or on Twitter. We really appreciate Brad comes back and spend his Saturday night to share knowledge with us. Let me first go through the past community news, then transfer the screen over to Brad. Past Facebook Live this month is on March 27th, hosted by Kendra Little. For more information, you can just follow past Facebook. I need to do this. Sorry. Past also looking for new sponsors, and you get $100 gift card for referrals leading to community sponsors. Also PASS has a career center for job hunters and employers. Like we mentioned before, PASS Summit 2018 has 2 registration offers now. And the first one is the Streamline one. As a Saturday Night SQL Virtual Group member, you can use this code VGSDRP9II when you register, and you will get over 200 hours of educational content from PASS Summit 2017. And the other one is our regular discount offer, which is $150 discount of your registration price, and the discount code is VGDISP9II. And these are the upcoming virtual group webinars by Cloud, DBA Fundamentals, and Women in Technology. What's not listed on that slide is our April sessions. We have 2 exciting topics lined up for our members. The first one is lesson learned from building a data warehousing solution by Cheryl Lee, April the 14th. And then Brad will come back and present Azure Machine Learning Studio for 4 tips from the pros. I can't wait to listen to both sessions. And as you may know already, past virtual groups have different topics and in different languages. You may join as many as you would like, and I've been listening to quite a few of them. And as always, you're more than welcome to join our virtual group, Saturday Night SQL, and and many others. Say like DBA fundamentals, they always have great topics. And women in women in technology and other ones. These are the SQL Saturday events. Well, March is over, so I guess it's April ones. And this is how you. This is the benefit when you join PASS to grow your career. You can get not only online educational content, but also live webinars, in-person meetups, events and conferences, networking, volunteering, and speaking opportunities. You may connect with PASS through Facebook, Twitter, and LinkedIn. This is how you may ask questions during the session. You may raise your hand if you want to interact with Brad directly. We'll unmute you, or you can type your questions in the chat window. All right, without further ado, let me transfer screen over to Brad.
Good evening, everyone. Thanks for that great introduction. So, like we've talked about already, my name is Brad Llewellyn, and I'm a senior data science consultant at Centelli Solutions. What I do is I help customers and individuals kind of unravel what is data science and how they can make it work for them. So throughout this presentation, what we're going to talk about is this is the wrong presentation. No, it's the wrong title on this presentation. So ignore the title. My mistake. That is not the title of this presentation. I will get that fixed. But title of this presentation is Azure Machine Learning Studio, making data science easier. So we're going to talk about Azure Machine Learning Studio today. It's one of my favorite tools in the Microsoft Analytics stack. And just to be clear, Azure Machine Learning Studio is the online interface. If you're looking for Azure Machine Learning Workbench, which is the tool that you can install on your machine, that would be a completely different topic. So a little bit about me. Like we've talked about my name and where I work. I've got the alphabet soup of certifications. I've been around for a little over 5 years doing analytics consulting. If you like what you hear today, I've blogged a lot about Azure Machine Learning Studio, so you can find that at my blog or on Twitter or LinkedIn at Breaking BI. You can also reach out to me directly at my personal email address there. And I'm also involved in the community a lot. I organize a local PASS group here in Charlotte called the Charlotte BI Group. And I'm also a frequent speaker at different PASS virtual groups as well. I do want to give thanks to the Saturday Night SQL group for hosting me and for having us all together. I want to definitely reiterate a lot of what was said earlier. Getting involved in the community is a great thing. In fact, it's one of the fastest ways to skyrocket your career. It's ways for you to learn things and for you to network with others. So please get out and attend virtual chapters like this. More importantly, attend your local chapters. Sign up to be a speaker. If you really like it, sign up to be an organizer or a volunteer. I can promise that all of those will skyrocket your career faster than you can imagine. So before we get started on talking about the tool, I do want to break down a little bit about what data science is so that we can understand how Azure Machine Learning Studio makes it easier. This graph we see here is the Gartner Analytics Maturity, I always forget the last word, Analytics Maturity Life Cycle or something like that. But basically it shows the cycle that organizations go through as they develop their analytics practice. So it starts down with the more simple questions of just what happened. Tell me what happened yesterday. What happened last week, last month? And then it gets harder and harder on the questions until we get to the point of, can you tell me what's going to happen in the future? Even more than that, can you tell me how I can influence that? How can I actually make it happen? Instead of telling me what customers bought yesterday, can you tell me what I need to do to make customers buy from me tomorrow? That's a much more valuable question. So on this, where does data science fall? What is data science? I like to say about the top, 2/3 of this is data science. Anything involved in that predictive or prescriptive space, where we're trying to predict the future, that's definitely data science. I also like to put data science in the diagnostic phase as well. There are a lot of different techniques out there for doing interesting diagnostics to have machine learning algorithms tell you when things are going wrong or tell you why something happened instead of you having to dig through the data. So those have interesting use cases. One of the other words I like to use, because data science is such a buzzword that it often gets overused, I like to use the term advanced analytics because that just seems to uh, fit easier in most people's minds. So that's what we try to keep in mind as we go through this talk. How do we make advanced analytics easier? For this agenda, we're going to talk a little bit about what is Microsoft Azure and why you would want to use Azure Machine Learning Studio. But the majority of this talk is demo. We want to see the tool, we want to interact with it, we want to see how it works and how easy it is, frankly. So the first question here is, what is Microsoft Azure? If we're going to use an Azure tool, it is important to understand what Azure is. So Azure is a managed cloud. That means that anything we would have on premises, we can tell Microsoft, I don't really want to manage this. I don't want to manage my VMs. I don't want to manage my networks. I don't want to manage my SQL servers. Can you do it for me? And Microsoft goes, sure. For a price, I will manage it for you. And that's what Azure is. You can, within a couple of clicks, spin up just about anything you want. In fact, for some of your more complex resources, like spinning up complex availability groups or read-only secondaries or even Hadoop clusters, which get very complex, Azure's 1 or 2 click experience makes those almost worthwhile just from that aspect. So if your organization isn't already in Azure, it should definitely consider it. With that in mind, this is kind of a lost bullet point at this point because it seems to be known, but there are still some organizations that think the cloud isn't ready for them, that it's not enterprise grade, that the security isn't up to par, or that it's not right for their organization. That's almost universally false at this point. The cloud can and will work for the vast majority of organizations, and I encourage you to look into your particular use case to find out how you can leverage it to really revolutionize the way you do analytics. And finally, it is fully managed and supported by Microsoft, so it takes a lot of that off of our plate. Instead of having entire teams of IT people whose job it is just to keep the lights on, they can shift towards doing things that actually make the company money instead of just costing it. So, what can you build with Azure? You know, we've got this cloud that we've just talked about how great it is and how we should all use it, but what would we ever want to build with it? At this point, there's very little you can't build on premises there's very little you can't build in the cloud that you could build on premises. In fact, there are a lot of organizations popping up now that are what's called cloud first, cloud only, meaning that they don't even have a physical footprint at all. Literally everything they own is virtual. They have no physical things to touch ever. And more and more organizations are going that direction. And frankly, there are a lot of use cases that the cloud opens up that you can't build things on premises. For instance, if you've got a complex big data use case on premises, it can take a lot of trouble to spin up a 40-node Hadoop cluster on premises. In Azure, that's incredibly easy. You can spin it up to 30, you can up it to 100, you can bring it back down to 30, all with a few clicks. Those are use cases that you could never do on premises without a tremendous amount of investment. So that's my spiel there. Now that we've talked about Azure, I know I'm going a little quickly there because the core of this talk is really to see the tool, but let's talk for just a couple minutes on why you'd want to use Azure Machine Learning as opposed to a lot of the other tools out there. How does it differentiate itself? So when we talk about that, I really like to frame it as looking at some of the common data science struggles we see in the industry. And I really like to harp on the picture here on the right side. For those of you that know your mythology, that's Sisyphus, whose his job was to push the boulder up the hill, but he was never actually able to make it to the top. So he would just continue pushing that boulder for eternity. And that's what a lot of analytics teams end up doing. They end up being cost. Organizations pump a lot of money into them, and not all those teams actually provide value to their organizations. And there are a lot of reasons for that. In fact, when we get into data science or advanced analytics, that problem even becomes more pronounced. I read an article a few months ago that pegged that about 80% of all data science teams are struggling to show value. So we're paying hundreds of thousands of dollars, even millions of dollars to teams that don't actually provide us any value. So what can we do about that as individuals? The first struggle that we often see is a lot of these tools have really steep learning curves. If anybody's ever tried to learn R or Python that doesn't already know them, they can attest that those are coding languages. They're hard to learn. There are tools like SAS and SPSS. They're difficult to learn. And that can really stop us from using our business expertise and our data professionals, and instead having to rely on programmers who may not have that particular domain knowledge. Also, anytime we deal with these coding languages, we have an issue of development, testing, and optimization. I'm sure that everybody listening to this has built things that never have any bugs, never need optimization. They always work, right? Except that's not the case. Everything we build has bugs. Everything requires testing and optimization, and it ends up taking a lot of time when we have to code all of that. In fact, that's what a majority of the time building these analytics practices is. It's just coding and testing. Well, one thing we'll see today is Azure Machine Learning Studio tries to take a lot of that off of our plates. It tries to make it easier and faster so that we can either succeed quickly or fail quickly. Either one of those providing value. One of the overlooked complications is that almost all of these tools that are normally used in these situations, like R or Python or SAS, they also require this really heavy knowledge of statistics. In order to even get started, you not only have to know how to program, but you have to know the difference between linear and logistic regression and boosted decision trees and neural networks. So for a data professional who may have very strong domain knowledge and strong databasing skills, they may struggle to pick up data science purely because the learning curve is too steep at that point. And finally, on some of these tools, productionalization can be time-consuming and expensive. I have a lot of respect for Microsoft recently in that they've invested a lot in making it easy to productionalize R and Python code. For instance, SQL Server 2017 supports both R and Python. Azure Data Lake Analytics supports R and Python. And there are some other tools out there that support them as well. But if we're not using those particular tools, if we're using maybe tools from another vendor or something like that, we may find that it can be difficult to get our R code to actually interact with our database. So those are all of the struggles that we're trying to overcome. Now that we've talked about struggles, how does Azure Machine Learning Studio actually fix these? How does it overcome these? First of all, it's a cloud computing software as a service. That means that there's absolutely nothing going to be installed on my machine today. I could easily use my friend's laptop and run this same presentation with no troubles. Also, we don't have to worry about scale. We can give it a few hundred records. We can give it a few million records. We can give it a few billion records, and it doesn't matter because it scales itself. We don't have to worry about any of that, and that's the advantage of software as a service. Next, it contains most of the popular, well-documented algorithms. So for most of our use cases, for probably 80% of all business use cases, you can find the algorithms you need already in Azure Machine Learning Studio. Moreover, they're extremely well documented. I've used R, I've read R documentation. I've used Python and read their documentation. I've used SAS and read their documentation. And Microsoft's documentation, honestly, I think is better than all of those. They do a very good job on Microsoft Docs of explaining exactly what something does, how you can use it, and even providing links to things like white papers to show the theoretical basis behind some of the things. So no matter how deep you want to go, the documentation helps you. Another thing is it's very easily accessible to data professionals. This is actually how I picked it up. I'm not a traditional data scientist. I don't have extremely strong R or Python skills. Mine are okay. Most of my skills are in more of the data engineering realm. So I come at it from that lens, which makes it a lot easier. And one of the ways it gets to be this easy is because it starts with a completely code-free GUI. You won't see us do any coding today. In fact, all we're going to do today is drag things onto the screen and connect them with lines. similar to that you'd see in SSIS or any other ETL tool like that. Another great thing about it is that it's only code free if you want it to be. We also have the option of integrating R, Python, or SQL directly into Azure Machine Learning Studio. And that's one way that you can really extend the functionality. It's a great way for more seasoned professionals to get more out of the tool. And finally, it seamlessly integrates into the enterprise data structure, because as you'll see at the end of this presentation, it takes less than 5 minutes to create an API that's already out on Azure and can be hit by anybody that has the key and the location. So now that we're done with that, let's hop into a demo and see what it's all about. If we go to search engine of our choice, we can just search for Azure Machine Learning Studio. Scroll down a little bit, click on one of the links, and it'll take us out to Machine Learning Studio, Microsoft's website. All we have to do is click Get Started Now. Once we click this, it loads. And the first thing that pops up here, we have the ability to create a trial or signing in or creating a workspace. I always like to point out that middle option there. Everybody on this meeting, everybody in the world, in fact, has the option of going out to this website and signing up for a completely free workspace. It's not a trial. It's not timed. It's actually a very generous size, in fact. You can get a completely free workspace. You don't even have to provide a credit card. And Microsoft says, we'll let you use Azure Machine Learning Studio for free forever. The only stipulations on it are it doesn't scale quite as well as the production version. If you want to use it within your organization for production use cases, I would recommend paying the $10 a month. But if you're looking to try it on your own or do a POC within your organization, the free workspaces are an amazing way to do that. So there's no financial reason why all of us can't get up tomorrow morning and start playing around with Azure Machine Learning Studio. So let's hop over to my other tab. This is studio.azureml.net. This is where everything lives. So as you can see, I've already got a bunch of stuff here because I've used it for a number of cases. But let's navigate around the screen for a minute. Over on the left side of the screen, we have a few different options. It starts in experiments. The experiment is the main workhorse of Azure Machine Learning Studio. It's where we're going to spend all of our time tonight, and it's where you'll spend 90% of your time in production cases. You can also look at any web services you have deployed. We have the ability to use notebooks, which we won't talk about today, but anybody that's used Zeppelin or Jupyter notebooks, these are the same types of notebooks, and that gives us a completely different use case for Azure Machine Learning Studio. In fact, it's one that I recommend people use that are even hardcore R and Python developers. It's a great way for them to develop as well. We can also look at our data sets, as well as trained models, and we'll talk about these in a minute. So there are two ways to get data into Azure Machine Learning Studio. One way is to manually upload your data set, and we can do that here under data sets. We can go to data sets. You can see there's a new button down here. We can click it from a local file, and we can upload any file we want. As far as the types that go, it's relatively limited because this isn't the typical use case. So realistically, it's mainly just CSVs and TSVs and those other types. You can upload a few different proprietary formats like SVM Lite and ARFF files. The other use case here is you can upload zip files, and that's a great way to upload R and Python libraries. For instance, if you want to use R and Python code in Azure Machine Learning Studio but need a custom library to do it, you can upload those through zip files. So it gives us some options. I've really only ever seen two use cases where it would be appropriate to get your data in this way. One is if you're just doing a POC and you have one CSV, you want to give it a shot, great, upload it and you're done. I've also seen organizations that are really wary about connecting manually pull off some approved data into a CSV and manually upload the CSV. That way there's no connection between their data and Azure. So what's the second way? We will skim over creating a new experiment for a second. And I'll show you this way. We'll come back in a minute and look more closely at what's actually happening here. But within our experiments, we have the import data option here. And over on the right side of the screen, we have a few different options. This is how we can live directly in our experiments import data, very similar to the way you would in SSIS with a data source. We can see our options here. We can pull data directly from web. This is good for either some government data sets are stored online. For instance, a lot of census information and whatnot can be found online, but also like football data and stuff like that can be found online too, which is interesting. But the majority of the other ones are connecting to your organization's data sources. So you can connect to just about any data source in Azure. You can connect to your big data through Hive queries. You can connect to Azure SQL database as well as on-premises SQL databases. You can connect to Azure Table or Blob storage, as well as Cosmos DB. It used to be called Document DB, and unfortunately they haven't updated this list yet, but Document DB is the same thing as Cosmos DB. Also, if your organization's data is in some sort of third-party data source, if it can be connected to using an OData feed, you can connect to it that way as well. I am not one of those kinds of experts, so I can't say for certain, but I've heard people say that if you can dream it, you can do it with a data feed connector. One thing to note here is Azure Machine Learning Studio really does want your data to be in Azure, and that is a little bit of a limitation. It's not great at sharing across clouds. That's a recurring theme across a lot of Azure data sources. Power BI is pretty good in the regard that it allows you to connect to everything, but this isn't like that. So if you have a problem with that, you can use CSVs or TSVs, but if we have time towards the end of the talk and people want to hear more, we can talk about ways to get around that limitation. So let's back up a minute. I only wanted to show you the import data source. If we go back to experiments here, we get to talk about one of the really interesting things about Azure Machine Learning Studio. In fact, it's the whole reason I'm using this tool today is because of this feature we're about to see. So if we go to experiments here, we click on new at the bottom. This is where most tools would start you. If you open up any other tool, Power BI or SSIS, and say I want to create a new workflow or whatever, you just create a blank one. And here you are. You're starting from scratch, and it may be tough to figure out what's going on. You might have to watch some webinars, read some documentation, maybe find a good walkthrough online somewhere. Azure Machine Learning Studio does one better than that. If we go back to new, we see, as we scroll down, a bunch of samples here, all different kinds of samples. We can even search them. So, I really want to learn how to use linear regression. We search linear regression. And it seems my internet is slow here, so let's not do that. But you should be able to search that. Unfortunately, I'm on hotel Wi-Fi right now, so it's not super fast. But you can actually search through these. And any experiment you see here that's interesting, for instance, we want to see cross-validation with regression, we can click Open in Studio. And again, I'm taking a risk on my hotel Wi-Fi doing this, but it opens up an experiment created by Microsoft here to show us how to use cross-validation for regression. This one in particular isn't documented very well. It depends on which one you open up as to whether they're documented or not, but it does give you a really easy way to show, here's how this would be done in practice. In fact, when I was learning how to use Azure Machine Learning Studio for the first time, I opened up a few of these samples and just walked through them step by step. What does this tool do? Okay, it pulls in the data from this location. What does this tool do? It cleans it using these different values. And I just walked through the experiment step by step, seeing what everything did, and found it was tremendously faster to start from a template than it ever was to start on my own. Also, since the Microsoft provided samples can be somewhat limited, they only cover a few use cases. There's maybe 40 or 50 of them. There's actually a much more interesting place to go. It's called the Cortana Intelligence Gallery. For those that want to be Microsoft data professionals, it's actually called the Azure AI Gallery now. Hey, they changed the name of it. That's cool. Well, it's now called the Azure AI Gallery. Thanks, Google, for correcting me. Here, you can find just about anything you'd want to see for a lot of the different Cortana Intelligence tools. And Cortana Intelligence covers almost everything in Azure related to data analytics. But here, we have a section called Experiments. So we click on Experiments, and down here, we can see a lot more experiments. There are exponentially more experiments here than there are in the Microsoft samples. And these are great because they're actually provided by the community. So people just like you go out and say, you know what? I'm going to use Azure Machine Learning Studio to create a really interesting use case for a neural network, a really interesting use case for natural language processing. And they'll create that experiment and they'll publish it here to the gallery to share with everyone else. In fact, I've often found myself, if a customer is asking for a type of analysis or a type of model that I don't really have much experience with, I've found multiple times that I can save myself just by going out to the Cortana Intelligence Gallery, or the Azure AI Gallery, as it's now called, and finding an experiment that handles that, and then just pulling it up and looking at it and saying, what does this do? Why is it doing this? So that's virtually, no matter how you want to get started, this is probably the easiest tool you're ever going to pick up. In fact, you could easily pick it up just by creating your free workspace tomorrow and playing around for an hour, and you'll be on your way to being an Azure Machine Learning Studio expert. So enough of the sales pitch. We're 30 minutes in. Let's get to actually building an experiment. So if we click on New Blank Experiment, we pull up what's called the canvas. Over on the left side, we have a list of what are called modules. These are what we drag onto the screen. These are what actually do the work. And on the right side, we have something called properties. This is where we'll make our selections. This is where we'll say, I want to use this type of transformation, or I want to use this type of model. So with that, let's look at how we actually want to solve this. What are we trying to do here with our experiment? As a showcase, I like to use one of the sample data sets, which, as you can see, there are a lot of these provided by Microsoft. So when you're looking to get started, you don't have to find your own data. Microsoft will provide some if you want it. I like to use this first one because it's nice and simple. It's called the Adult Census Income Binary Classification Dataset. And what it is it is a group, it is a selection of people, specifically demographic information about those people. So line 1 is going to be a person who's going to have a particular age and a particular race, a particular job, a particular amount of a financial weight. They have capital measurements there. They have country of origin is one of the things. They have a lot of different information about that person. And at the very end of the data set, they have a classification of their income. It says, do you make greater than 50K or do you make less than 50K? Our goal for this experiment is going to be, in the next few minutes, can we build a predictive model that predicts a person's income based on those demographic features? And we're going to see how easy that is. So the first thing we want to do is we want to take a look at this data set. I drug it onto the screen. That's nice and easy. How do we take a look at it? One of the really cool things about Azure Machine Learning Studio is I can right-click on anything, hover over the outputs, and there's an option here called Visualize. This exists for almost every module in the entire studio. And what it does, it lets you look at the output of that module. In this case, the output of the module is just the data itself. So we can see our field names up here at the top. In the top left corner, we can see how many rows and columns are in our data set. We can see we have about 32,000 rows and about 15 columns. And we can see what those columns are. You've got age, work class, education, marital status, blah, blah, blah. And at the end, we have that income column we were talking about. We can scroll down through this data set. It'll show you about the first 100 or 200 rows and maybe the first 30 or so columns. So if you have a really large data set, like 100,000 rows by 45 columns, it's not going to show you the entire data set. It's only going to show you a small chunk of it. But this does give you a really good indication of what's going on inside your data. What I really like about it is at the top here, we can see it provides histograms for every single column. We can even change these to box and whisker plots using this option here if we like. It allows us to quickly scan across our data and see anything that sticks out. For instance, race. I see race. Oh, I click on race, and all of a sudden a histogram comes up over here, and I can see what's happening. It says for this data set, 85% of all the records here are white versus 9.6% are black. And we can see that just from our data. We don't have to build complex SQL queries and group bys and maybe even pull it into Power BI to do a bunch of investigation. It's all right here at our fingertips. So a lot of our initial data investigation here becomes relatively simple. Let's think back to our original question. Our goal here is how do we predict this income value here? We said this income has less than or equal to 50K or greater than 50K. We want to predict this value based on the 14 other columns in this data set. Specifically, we want to be able to predict these values for a new person that walks in. We have 32,500 records with results, 32,500 people for which we know their income. A new person walks in the door, a new person signs up for our website. I want to be able to predict their income because that's what's valuable to me, something I don't already know. So how do we do that? First thing we could do, we could walk through some of the things. There are some more complex steps that we talk about in a different presentation, like feature engineering and data cleansing. But one of the things about Azure Machine Learning is we don't actually have to do any of that. It certainly helps, but we don't have to. It will actually guide us through the process of going as quickly as we want. So we could go down to the machine learning section here, go down to initialize model. And here we have 4 different classifications of models. This is about the only bit of knowledge we need to have to get started, and it's very minor. In fact, I expect everybody on this call to be an expert at this by the time we get off this call, because it's that simple. So the 4 options are anomaly detection, classification, clustering, and regression. Anomaly detection is what it sounds like. It's find me something unusual. That's not really what we're looking for in this case. We're not looking for something unusual. We have 2 choices and we want to pick one. So classification, what's that? Classification is exactly what we just said. It's I have a few options, pick one. Clustering is different from the other ones because it's not actually looking for something. Clustering says, I've got a big pile of data here. Can you tell me how many groups are here? How many different types of people are in my data set? That would be a good question for clustering. And finally, we have regression, which is kind of like classification, except instead of predicting a category, it predicts a numeric value. So for our case, we're predicting is income less than or equal to 50K or greater than 50K? If we want to turn that into a regression problem, we can say, let me predict their exact income. But that's not what we're doing today. So in our case, we just know I need classification. I click on classification, and it gives us a lot of different options here. The important distinction here is there are 2 main sets here, multi-class and 2-class. Those are exactly what they'd sound like. So a 2-class classification algorithm tries to pick between 2 options. And that's what we're doing here. We have a 2-class problem, less than or equal to 50K or greater than 50K. The multi-class option is, say we had 4, 5, 6 different options. That's when you start using multi-class. So now our question becomes, which of these models do we need to pick? In practice, I almost always use all of them. I use every single model. In fact, there's 15 different combinations here. We talk about that more in the follow-up presentation to this. But I will pick all of them and see which one performs the best, see which one gives me the best results. For our case, we want to move somewhat quickly, so I'll just drag my favorite out there. I use 2-class boosted decision tree most of the time. There have been a lot of use cases studied across the data science field, and for 2-class classification algorithms, boosted decision tree is usually the best model. More often than the other models, it is the best. That doesn't mean it will be the best for your use case, and it certainly doesn't mean it's always the best. But in general, it's a good choice. Well, when I'm doing this in practice, like I said, I always use all of them and then let that decide for me. show me which one's the best using my data, not just me telling it which one's the best. So once we've dragged that out there, we need to take the next step. And this next step is what's called training. So this model we've initialized, we've dragged two-class boosted decision tree out there. What that does is it basically creates an empty math formula. It's a math formula that's waiting to be populated with our data. In order to do that, we need to do what's called training. So we can drag a trained model out here. And all the trained model is going to do is it's going to take our data and combine it with this empty math formula to come up with a completed math formula, a model that we can then use to predict values. So we can see how easy it would be to connect these. We just click on, okay, I've got one model. I've only got one option here. Okay, goes to green. We select the other output, only have one option. I'm having some graphical issues here. It goes to green. So once we've connected our untrained model in our data set to this training, we have to tell it one more thing. And what we have to tell it is the label. In machine learning language, label means what you're trying to predict. In our case, we're trying to predict income. So we click column selector, and we get this nice, easy column selector we can use. So we could drag income over. And I have to click OK. It's not giving me the OK option, which is unusual. That's going to be a problem. My apologies. I've done this quite a few times and never had this issue. Let me try something real quick. Okay, I have to admit this is a problem I don't know how to get past. The GUI seems to be forsaking me, which kind of really kills the point of this presentation. Okay. Let me come back to that, and hopefully I will have a way around it. My apologies, we will be in trouble. So if we were to train our model, we would end up with a trained model that's been trained using our entire data set. And that's good because it's a model that's been trained with a lot of data, but it leaves us with an issue after that. And the issue after that is, how do we know if that model's any good? And that gets into something called model evaluation or testing. So in general, to make a fair test, you should test the model with data it hasn't seen before. And the way that's normally done is by training and testing sets. A really simple way to do that is by splitting our data in two parts. So we feed one part of the data to train the model and the other part of the data to test the model. That gives us a good representation of how that model might work at predicting new values. Remember, because it's not fair to test the model using data it's already seen, because it should be pretty good at predicting that. Our goal is to see how good it is at predicting new values. So in order to do that, just search for split, and there's a module called split data. So we drag it under our data. We connect our data to it, goes to green as always. And now it's going to split our data into two pieces. The first piece, the fraction here is going to go to the left side, and the remainder is going to go to the right side. So I usually use 0.7. The value you put here generally doesn't make a huge difference, but if you're worried about it, you can always try multiple options and see which gives the best result. What we want to do is we want to train our model using 70% of our data and then hold that other 30% of our data off to test it. So now we're back to train model. We take our left side of our data out. There it is. See this check mark at the bottom? That's what we weren't having before. My apologies for not being able to get that working, but now we've put income in there and we click OK. Yeah, now it works. So now we have the ability to train our model, and let's take a look at what that looks like. In order to run this, we just click this run button at the bottom. Nice and simple. And it's going to take a few seconds. It's going to run. And as you can see, it runs virtually immediately. In general, Azure Machine Learning Studio is very, very fast. I've rarely had cases where it runs slowly. The only cases where I ever have to wait for anything is I like to build these really large experiments that test hundreds or even thousands of different models. And in those cases, it does take some time. But I often use that right before I'm going home for the day, so I'll let it run overnight and then come back the next day and check on it. But in general, for development cases, it's almost never a problem. As you can see here, it runs lightning fast. So like everything else, we can right click on our train model module and we have a visualize option, same as we had before. Once this graphic comes up, we're going to see a decision tree. So this is the result of that train model module that we saw. It creates these decision trees that are now populated. Ooh. It's very large. There we go. So this decision tree here, basically a decision tree is a set of decisions, as they're called. So it's a set of splits. At the top of this tree, all of our data comes in. And what it does is it makes a decision here. It says, for this column, does the marital status dot married civ spouse feature or column, does that column have a value of less than or equal to 0.5? If it does, then it goes to the left, to the true side. If it doesn't, it goes to the false. And it keeps splitting our data over and over again until it becomes very comfortable making a decision. And when it does that, we get to one of these blue nodes here that are called leaves. And you can see this leaf predicts less than or equal to 50K for income. And it does that hundreds or even thousands of times. One thing that's interesting to note about this is for some of our more eagle-eyed viewers, the marital status dot married civ spouse column didn't actually exist on our dataset. Our dataset had a column called marital status, and it was a string column. It had text values in it. One of the values in that column was married civ spouse. Most machine learning algorithms and other tools would error out right there. Say, okay, I can't handle text. Don't give me text. Turn everything into a number. And then you have to get down to, do you know how to turn things into numbers? The technique being used here is something called indicator variables or dummy variables. It's also called one-hot processing. But basically what it does is it takes an entire text column and it splits it out into multiple columns. So for instance, this marital status column is now, I don't know how many values it takes. Let's say it takes 5. Marital, married civ spouse, single, divorced, whatever. Pick your values. Each of those unique value becomes its own column. So in this case, marital status married civ spouse tells you whether or not that person was married. To put that into context here, married civ spouse being less than or equal to 0.5 means that it has a value of 0, which means that they are not married. So this question, this first decision here is really, is this person not married? If they are not married, it goes left. If they are married, it goes right. This isn't necessary for what we're doing today. This is just interesting, and I like to show this because this is one of the best decision tree viewers I've ever seen in my career. So I really like to point it out, because if we're using some of the other tools, they don't necessarily have tree viewers that are this interesting. And I found that people just like looking at decision trees for some strange reason. So now that we're done with that part, we've trained a model. Now we need to test our model. We need to see, is this model good enough? In order to do that, we have something called scoring. We have score model here. Scoring a model means you take a trained model. You take this math equation that's been filled in, these decision trees that are already completed, and you use them against a data set. So in this case, we're going to take the other part of our data set, the 30% of our data set that we left out, and we're going to rub it up against our trained model. And we're going to say our trained model needs to predict for all of these people, however many are in there. We want that model to predict what the income of those people is going to be. This is even more important because we already know what their income is. So since we are getting the model to predict what their income is, we now have a true value and a predicted value, meaning we can compare how good the model actually does. So we can run that real quick. And as we saw before, it's not going to take long. Right-click on Score Model. We can go out to Visualize. We visualize this. We can see it's 9,768 rows, which is about 30% of our original 32.5 thousand. Except now it has 17 columns instead of the original 15. So if we scroll all the way to the right, we can see our true income column here. But beside it, we can see scored label. That's the predicted value. So we have a true value and a predicted value. In fact, it also gives us the scored probability, which as we get more advanced, we can utilize that instead of the label. But for now, it's easy enough just to use the label. We could scroll down through this and see things. For instance, we have a mismatch here, but we really don't want to look through this using our eyes, especially because it's 9,768 records. Fortunately, Azure Machine Learning has a really easy way to handle this too. We have something called Evaluate. We just drag Evaluate out. We connect our scored model to that, and we run it. You see, all of this was done in, 5 different modules, none of which we had to know the code for, and all of which, if we knew basic machine learning language like training, scoring, and evaluating, all of which would be second nature to us. So once we right-click on Evaluate Model, click Visualize, it shows us a lot of information. These are standard metrics for evaluating models. We won't get into exactly what these do, but these would be something that a veteran data scientist would be very comfortable with. These are the types of metrics they would use to determine how good their model is. For us, we just get to use it for some of the more interesting metrics. For instance, we have accuracy down here. This tells us that our model has an accuracy of 86%, meaning 86% of the time it predicts correctly. We can even see what's called a confusion matrix over here, so we can see where that actually falls. For instance, over 6,000 records were what's called negative, which in this case is less than or equal to 50K. Over 6,000 of those were negative and were actually predicted. And then we can see the different breakdowns and whatnot as well. We could dig into this all day because there's so much information here. Why that's important is because it's right at our fingertips. It's that easy to look through. And as we get more and more advanced, we can continue to utilize it without ever having to learn how to code all that. So we've seen that our model has an 86% accuracy. Let's say that's good enough for us. Let's say 86% is great. Now we want to productionalize this. We want to say, okay, I want to put this out on Azure so that the rest of my organization can use it. This is where a lot of other tools might have trouble. This is where you need to start talking to DBAs to get your R code implemented. You got to talk to your IT team to get that set up. Oh, that's so much work. Here, we have a button down here that says Set up Web Service. In our case, we want a predictive web service because we want a web service that predicts values, not a web service that retrains models. So we click that. We get a nice little graphic that we'll see. It collapses everything down and creates new inputs, and yay, it looks nice and fancy. What it's done is it's created a brand new experiment for us that's now a web service. We now have a web service input and a web service output, and we'll talk about what that means here in a second. What's really important to look at here is this experiment here. This is a trained model. Instead of retraining the model every time it runs, what it's done is it's saved our model. That model that has 86% accuracy has now been saved out to the Azure Machine Learning Studio workspace. So, and since it's saved out there, that means every time that we send a record up to be scored, every time we say, okay, a new person is logged onto my website, I need a prediction now. It ships the value up into this input, runs it up against this already saved model, so it's just a quick mathematical operation, and then it scores it, and out it goes. It's that fast. And in production use cases, I have never seen anybody have an issue with the speed of these. So it is lightning fast when you run it in production. So we have this web service, and we've created it, but it's not actually deployed yet. So how do we get it deployed? First, we have to run it. That's a quirk of Azure Machine Learning Studio is it's technically a new experiment, so you have to run it first before you can deploy it. But as with everything else, it only takes a second. So now it's run, we want to deploy this out. We want to deploy this to Azure so that everybody in our organization can use it. We have the deploy option here. We can click Deploy Web Service New. It takes us out to the sister website. We were at studio.azureml.net. This is services.azureml.net. This is where your services will sit. And we can name this whatever we want to name it. Sat Night SQL 01. And here's where we get into some of that administrative piece. You do have to assign it a storage account and a price plan. My subscription from Microsoft has been gracious enough to give me a free plan, but there is a plan called Dev Test that you can use in your organization that's also completely free. So the workspace is free and the web service plan is free. Once you productionalize this, if it shows value, then you can swap over to a paid web service plan that gives you a lot more hits. We give it a name and we click this deploy button here. It's that easy. As you've seen, minus all the talking, I've talked a lot and we had a little bit of a technical hiccup there. But honestly, I could have done all this in 5 minutes. That's how fast it is. And none of it required any code. There was absolutely zero chance of me mistyping something, of me making a logical error. It was that quick. And after it deploys, it takes us out to our dashboard. Here's where it gets really good. This is the big selling point for me, because I'm a data professional. I can drag and drop data sources. I can use that connecting the lines. I understand what training a model means. I understand what scoring a model means, but I don't know how to productionalize an API. That's web development stuff, man. I'm not that type of geek. I bow down to those that have that skill. So how do I use this? How do I say in SSIS get this to run? How do I get this to run in SQL Server? How do I get this to run in Power BI? If we click on this consume option over here, it gives us all the technical stuff like security keys and URIs. But what's much better for me is I scroll down and we have sample code. Specifically, it gives me the exact code I would need to productionalize this in C#, Python, or R. So no matter which coding language I need to use for my particular application, it does all of the work for me. I've literally copied and pasted this and run the APIs before. That's how quickly it runs. So the point of all of this was to show that we were able to, in 30 minutes, 27 minutes actually, productionalize an API that predicts a user's income as soon as I log onto our website. And we were able to do that with all of that talking. In fact, I could have easily done it in 5 minutes had we not talked about every step. Throughout my time using Azure Machine Learning Studio, and I've used it quite a bit, I often find that what would take a traditional data science team maybe 4 weeks to do. Let's say 2 data scientists working for 4 weeks in R and Python to develop a machine learning model that's productionalized. I'm often able to do by myself in 1 or 2. We can cut the time in a quarter. And that's important for 2 main reasons. One, when your organization wants to use these tools, they really don't want to wait 4, 6, 8 weeks to get answers. They want answers now. But even more important than that, as we're building these solutions, we often find that maybe we weren't on the right track. Maybe what we built wasn't perfect. Maybe we failed, as it's called. And Azure Machine Learning Studio allows us to fail fast. Fail fast is a very common term, and what it allows us to do is it allows us to iterate, meaning by the time it takes a traditional team to build 1 algorithm, I've already built 4, meaning that my chances of success are far greater. So I want to thank you for taking the time with me tonight. I am giving a follow-up to this presentation here in about a month. It's called Azure Machine Learning Studio, 4 Tips from the Pros. That gives all of you plenty of time to start using Azure Machine Learning Studio and build up your skills. And in that presentation, we take what we learned today and we build on it and show, yeah, what we did today was nice and easy and all of that. How do we build real production-worthy use cases? How do we build a model we'd actually want to put in production? And that's what that talk is all about. I'm going to open up to questions at this point, but you're more than welcome to reach out to me at all of those links. And otherwise, have a nice night.
Hey, Brad, we have a few questions. One of them is one of the pushbacks going to cloud is a security concern. Any insights by Jacob?
Sure. So, like we talked about before, you don't actually have to connect your organization's data to Azure to do this. If you can put your training data set in a CSV or a TSV or some sort of text format like that, you can manually upload that file, assuming it's clean. And if you can't go to the cloud at all, well, that is a problem. But if you're allowed to put that one CSV up there, you can actually train and test your model using that one CSV. And then you can productionalize this API. And there's a lot of security reasons behind the API. But basically, APIs are far more secure because nothing's ever actually stored. So you're just shipping it up and getting it back. So that may be a way to work around your organization's security concerns. But of course, if your organization says no cloud ever for any reason, then this isn't the tool for you. Maybe something like R or Python integrated in SQL Server might be easier.
Yeah. So as a DBA with no experience in data science, where do I start? And what kind of tools should I use, should I learn to get my foot into the world for data science? Any links and resources that you can provide?
I'm really glad that person is watching this presentation because you're exactly who this is for. So the reason I love this tool so much is not because it outperforms R or Python, because honestly, in a good many production use cases, you can find reasons why R or Python are better. The reason I really love this tool is because of how easy it is to use. A DBA likely has SSIS experience, and as you can see, this tool is not that different from SSIS. In fact, it's a lot easier than that. So if you read just a few of my blog posts, I have blog posts that walk through all of this. Just a few of my blog posts will get you up and running in Azure Machine Learning Studio to where you can build your own experiments and then you can play. Instead of reading, instead of watching other people build stuff, you can actually build it yourself. And that's a much better way to learn.
Yeah, makes sense. How do we set the cross-validation steps?
Oh, that's an interesting question. So there's another module called cross validate model. We don't use it in here, and honestly, I don't talk about it in my 4 tips from the pros talk either. But it is an interesting use case. But as with everything we saw tonight, there's simply another module that you can drag out onto the screen that does cross validation for you.
Cool. If the accuracy is not high enough, do we have access to tune the model?
Absolutely. In fact, let me go back and showcase that because it is quite easy. Where was it? It's out here in experiments. So we go back to our experiment. This is what we saw before. The screen's getting a little crowded. My apologies. If we click on our initialized model, over here on the right side of the screen, we have these hyperparameters, as they're called. These are all of the pieces that make up that math equation. So we can actually change these. Better than that, there's a tool or there's a module here called Tune Model Hyperparameters. And this is actually one of the pieces of my extended topic that I'll be giving in a month. But what this allows us to do is this allows us to, instead of just creating one model here like we did, we can create 10, 15, 20, 100, 500 models. Having it randomly select, or we can give it a grid of all different sets of hyperparameters, and it'll tell you exactly which ones provide the best possible results. And in practice, that's exactly how I do it. That's how I choose the best model is by letting it run hundreds of different models and pick the best one.
Well, continue with that question. I'm wondering if you could build your own models.
So if you want to build your own, and that's a bit of a tougher question. One, you might want to ask why you would want to build your own. Uh, there's uh, there's a term called parsimony, which means simplicity. And basically, if you can ever phrase your question in a way that's easy to use a pre-built algorithm, then you should. However, not every use case can be done like that. There are cases for custom building algorithms. And in order to do that, we can use R and Python scripts directly in Azure Machine Learning Studio. So if we want to use an algorithm that isn't supported in the drag and drop interface, assuming we can find an R or Python library that can do it, or we want to code our own in R or Python, we have that option here.
That's wonderful. So, can you show more detail for the last step of using the API to show how the business users can use this predictive model?
Sure. So there's not a lot I can show, but we can certainly talk about it. So what's been done here is this API has been created in Azure. So it's now out there. In fact, it's located at this location right here. And in order for a business user to hit it, they would somehow need to get access to it. One of the interesting things you have here is you can access that API through Excel. There's a plugin to do it. In fact, if we click this Excel 2013 or later option, it actually gives us a connection to it already. So they could use Excel to do it, and in some use cases, this might be a good way. Of course, this isn't a scalable solution. Excel is never the scalable solution. So if you're just trying to test or give business users access to something every once in a while, great. You can use the Excel add-in. If you want to, say, integrate it into your data pipeline, then you would need to use this code down here. For instance, you can use C# code in SSIS. If you're using SQL Server, or actually it's just SQL Server. If you're using SQL Server or Azure Data Lake Analytics, then you can integrate with the R or Python code. But we have the option to programmatically hit those APIs in our pipeline, or allow the business users to use Excel to hit it directly if they would like.
Mm-hmm. So another question is, can you explain the steps on how to make the model more accurate?
So that's the entire point of the next talk. So I can't go over all the steps. We did have someone talk about tune model hyperparameters earlier, and that's one way. So taking these hyperparameters and finding the best possible combination. You have other options like cleaning your data. For instance, no data is perfectly clean. There are different options for cleaning it, and of course, there's a clean missing data module that handles that. There's a topic called feature engineering, which basically means taking your data set and creating more columns. If none of that works, you also have the option of adding more data. You can go back and find more data, or you can find additional columns, or you can integrate additional data sources. There's a lot of different options to make your models more accurate, but you could spend the rest of your career learning all of that because that space is so large.
Right. Would you be able to go through the web service plan? And I remember that part you mentioned that you had to pay for it.
Sure.
And there's another way you don't have to pay for it. Would you be able to demo that?
We can look at the pricing directly on Microsoft's website. One thing I love about Microsoft is all their pricing is right there on their website. So we can see here, we have 4 different options for Azure Machine Learning Web Service Plans. It's important to note that Azure Machine Learning Web Service Plans are not the same thing as app services, which is how, say, a web development team would productionalize their APIs. They are 2 completely different things, so that they are priced differently. But we have the option of making a dev test web service plan, and you can make these directly in the Azure portal, same way you make anything else. You can create a dev test plan, which is completely free, with a few stipulations. You are limited at 1,000 transactions a month, meaning hitting it 1,000 times, 2 total hours of compute, and you can only have 2 web services on it.
Oh,
Also, you can only have one of these in your entire subscription, meaning you can't just keep spinning up multiple dev test plans and utilizing them. You can only have one. Of course, 1,000 hits and 2 compute hours a month probably won't suit your production use cases. So then you get to start upping to the web service plans, and that's when you start paying. Or you can have a pay as you go plan where you just pay for every web service transaction.
does that mean like when you use it, you pay for it? Otherwise, just like use the cloud stuff.
Mm-hmm.
Okay.
So yeah, if you picked one of these standard plans, it would bill you every month whether you use it or not.
Uh-huh.
But if you use the pay as you go plan, which I don't even know if that's still an option anymore because it's not listed here, but you used to be able to have a pay as you go plan, which would only charge you if you use it. Granted, the plans are more efficient if you can utilize them.
Right. Oh, that's cool. Um, I guess that's. Oh, one more question. I thought I have to. In your experience, how if business using the result from the machine learning?
So that's a great question, and that's a question you should always have answered before you ever start the analytics process. All of this should really hinge on what does the business need. There are a lot of interesting problems we can solve using machine learning. But if they don't provide value to the business, then we're going to have a hard time getting them to pay us for it. So we often start with that question of what's a problem for the business? Can it be solved with analytics? And more specifically, can it be solved with machine learning? Because that's where Machine Learning Studio really comes into play. And once you ask all those questions, once you have those answered, then how the business uses it is really just up to how they need it. It could be integrated into their SQL database. It could be in their Excel reports, like we saw. It could pop up on their Power BI dashboards. Wherever they need it is where we provide it.
Speaking of that, what kind of data source can be used for the Azure machine learning?
That's so. I promised at the beginning of the talk that if we had time, I would talk about the data sources again. If we go back and let's drag out that import data module again. Drag that out. We can take a look at the right side here. These are the data sources we can use, and all of them are Azure. With the exception of the data feed provider, which is in Azure, and the on-premises SQL database, which requires what's called a data management gateway. So if your data is in Azure, you can likely hit it using Azure Machine Learning Studio. If your data isn't in Azure, we have a few options. You can pull it down into CSVs and upload it manually. That's one option. Remember, all we need that data for is training the model. So if we can do a one-time download and train the model using that data, the API itself is just out on the web. It doesn't matter where it lives. And you could certainly hit that API from Amazon or from Google or from your on-premises installation with no difficulties. And you also have the option of pulling from those other sources. For instance, Azure Data Factory is very good about pulling in data from Redshift or Google or any of those other cloud options. So the answer is if it's on Azure, you can hit it easily. If it's on one of the other cloud providers or on an on-premises installation, there may be a few more steps required.
Okay. So if your data set is too large for a CSV file, would you think you can just cut into certain amount in order to be able to upload?
So that's certainly an option. In fact, I've actually done that before. There's no size that's too large for a CSV per se, but I have noticed that if you upload extremely large CSVs, in fact, I uploaded a 10 gig CSV once to Azure Machine Learning. You will often find that some of the modules just crash. Too much data.
Right.
Because Azure Machine Learning Studio is not meant to be a big data science solution. If you need that, then you're better off using something like HD Insight Spark or Azure Data Lake Analytics. But if you really need to get that data in, you can do things like chunking it out into multiple solutions and things like that. And Azure Machine Learning will scale as it needs to.
Oh, okay. That's pretty cool. I think that's all we have tonight. Are there
Okay.
any questions? I think that's all we have. Okay, thank you so much, Brad. This is a great presentation. I really appreciate you come back and spend another Saturday night with us and share your knowledge. This is wonderful. And as always, we're gonna post this on the YouTube and share the links. Would you be able to also share your slides?
Absolutely. I don't have many slides, but I will share them with you.
Okay, cool. Then I'll post the slides to our website.
Okay. Thank you.
Thank you. And thank you everybody for joining. And we'll see you next month.